All right, let's talk about something pretty wild. Imagine one of the most famous skyscrapers in New York City. Now, picture this. Hidden way up at the very top, there's this enormous weight just sitting there, secretly keeping the whole building from toppling over. It's an incredible story of genius design, a nearly catastrophic mistake, and a nail-biting race against time.
So yeah, that's what we're talking about today. This is the story of the Citicorp Center, which you'd now know as 601 Lexington Avenue. And we're going to get into its secret weapon, a true marvel of engineering that was built to solve a problem that really no one had ever faced in quite the same way. So what exactly was this problem? Well, back in the 1970s, Citicorp wanted to build its new headquarters on a fantastic block in Manhattan. But there was a big catch. A church sat right on the corner of the land, and they made it very clear they were not moving. So the only way to get the tower built was to build over the church, which forced the architects to come up with a truly radical design.
To get around the church, the designers had to do something pretty much unheard of. They couldn't put the building's main support columns at the corners, where they usually go. Instead, the entire skyscraper rests on these enormous stilts that are placed right in the middle of each side. Now, as you can imagine, this created a massive stability problem. But it also led to a moment of pure genius from the building's engineer, Bill LeMessurier.
LeMessurier's brilliant idea was to create a kind of skeleton of massive V-shaped braces, or chevrons, all the way up the building's exterior. You can almost think of it like a giant game of Jenga in reverse. By designing it this way, he could strategically take out certain columns, forcing the building's incredible weight to travel down through these diagonal braces and land perfectly on those stilts. It was such an elegant solution, but it created a totally new and pretty dizzying problem.
So because of this super innovative chevron system, the building was incredibly light for its size. We're talking only about 22 pounds per square foot. Now, while that's really efficient, it also meant the tower was extremely likely to sway in the wind. And not just a little sway, enough to make the people working inside physically sick. Not good.
Now, the traditional way to fix this would have been to just add thousands and thousands of tons of extra steel to make the whole thing stiffer. But LeMessurier suggested something way more clever. The first ever tuned mass damper to be built right into a skyscraper.
And this is the heart of the story. The team built a colossal 400-ton concrete block on the top floor. The construction crew nicknamed it the Great Block of Cheese. Here's how it works. As the wind pushes the building one way, hydraulic systems let this giant block slide in the opposite direction, which basically cancels out the motion. It's physics, but it feels like magic. And get this, the damper was so effective that it was designed to reduce the building's sway by about half. That was enough to make it perfectly comfortable for everyone inside, even on the windiest of days.
And here is the financial genius of it all. This one single piece of technology saved the project about $4 million because they didn't need to buy and install 2,800 tons of extra steel. I mean, what an absolute game changer.
So, the building is up, it's a huge success. But this is where the story takes a terrifying turn. It's the summer of 1978, about a year after the building opened, and LeMessurier gets a phone call from an engineering student who's actually writing his thesis about the Citicorp building.
So, as LeMessurier is on the phone, kind of patiently defending his very clever design to the student, a weird thought just pops into his head. He suddenly realized that all of his original calculations had been for perpendicular winds. Winds hitting the flat faces of the building. He had never properly checked the stress from winds hitting the corners.
That nagging thought, it just wouldn't go away. So he went back to his office to double-check the work, and what he found was chilling. He quickly saw that quartering winds, the ones hitting the corners at a 45-degree angle, put a dramatically higher amount of stress on certain joints. And then, to make matters so much worse, he learned that a change had been approved during construction that he wasn't aware of. The key joints were bolted together, not welded shut like in his original design.
Okay, just look at the math on this slide, because this is where it gets truly terrifying. His new calculations showed that with those quartering winds, some joints were under more than double the stress they were ever designed for. But then, when he applied the correct safety factor that the code required, he realized some connections needed 14 bolts. They had only used 4.
After running the numbers through a proper wind tunnel analysis, the situation was even worse than he imagined. A storm strong enough to cause a catastrophic failure. It wasn't some theoretical once-in-a-thousand-years event. It was a 1-in-16-year event. There was a very real, very scary chance the building could collapse that very year.
So, LeMessurier was faced with a devastating choice. He could have kept silent, crossed his fingers, and just hoped for the best. Or he could risk his entire career and reputation by coming forward. He made the right call. He immediately informed Citicorp's leadership, and they put a top-secret plan into motion.
They codenamed it Project Serene. Every single night, a team of welders would sneak into the building after everyone had gone home. They'd rip open the drywall, weld these massive steel plates over the dangerously weak bolted connections, and then patch everything up so it looked like nothing had happened before employees arrived the next morning. Nobody, not a single person working in that building, knew their workplace was on the brink of disaster.
The repairs were a desperate race against time, with hurricane season right around the corner. And then, with the work only halfway done, their absolute worst nightmare started brewing out in the Atlantic.
A massive storm, Hurricane Ella, was on a direct path to New York City, and it was powerful enough to produce the exact kind of quartering winds that could bring the whole tower down. LeMessurier got emergency generators for the block of cheese, because that tuned mass damper was now the building's absolute last line of defense. Behind the scenes, officials were secretly preparing to evacuate 10 square blocks of Manhattan.
For 24 agonizing hours, the city, the engineers, and that secret crew of welders basically held their breath. The storm just stalled off the coast, and no one knew which way it would go. And then, at the very last possible moment, it turned and headed out into the open ocean. A catastrophe of almost unimaginable scale was avoided by a razor's edge.
With the immediate threat gone, the crews were able to finish the repairs. The building was now safer than it had ever been, strong enough to withstand even a 1-in-1,000-year storm. And what's just amazing is that this whole story was kept completely secret from the public for almost 20 years.
But when the story finally broke in 1995, it wasn't seen as a tale of failure. It actually became a landmark case study in engineering ethics and professional responsibility. Because of this, building codes were updated to include quartering winds, and the tuned mass damper, the device pioneered in Citicorp, is now standard practice in super tall skyscrapers all over the world, from Taipei 101 to the towers being built today.
So the next time you look up at a city skyline, remember the Citicorp Center. It really shows us that the most sophisticated part isn't always the steel you can see, but maybe the massive, hidden weight you can't, working silently day and night just to keep the impossible balanced.